Good morning, everybody. Today we started our new topic analog to digital converter. Introduction of ADC. What is ADC? Why ADC is needed? Application of ADC and AD conversion process. In today's lecture, we covered these three topics. So what is ADC? An electronic integrated circuit which transform a signal from analog to digital form, or we can say from continuous to discrete form, is known as analog to digital circuit, digital conversion circuit. Here analog signals are directly measurable quantities and digital signals only have two states. For digital computers we refer to binary state, or we can say 0 1 state, and the second thing is they can also known as high level or low level signal stage. So why ADC is needed? Microprocessor can only perform complex processing on digitized signals. So for any type of complex processing is required digital signals, or we can say for any type of digital devices we required only digital signal. And when signal are in digital form, they are less susceptible to the deleterious effect of additive noise, and ADC provides a link between the analog world of transducer and the digital world of signal processing and data handling. ADC are virtually everywhere where an analog signal has to be processed, stored, or transported in digital form. Some example of ADC uses are digital voltmeter, cell phone, thermocouples, and digital oscilloscope. Microcontrollers commonly used 8, 10, 12, or 16-bit ADC. Our microcontroller uses an 8 or 10-bit ADC, and this shows the ADC process. Basically, we applied input continuous signal or analog signal to a sample and hold circuit. In sample and hold circuit, this continuous analog signal is converted in sample and hold waveform, and then it applied to quantized and encoding, where this sample and hold signal is applied to a quanta, means for each sample and hold signal a quantum is applied, and then that quantum have the encode in 0 and 1 method. So basically there are two steps for ADC process: sampling and holding, and quantizing and encoding. So this is the brief of sampling and holding signal. Here is the continuous signal. This continuous signal is passes through the sampling pulse, and then it converted this continuous signal into the sampled signal. So here is the sampled signal, and there is this signal is then applied to the hold circuit. So sample, after sample and hold circuitry we get this signal. Basically the holding signal benefits the accuracy of AD conversion because it hold signal for levels, and minimum sampling rate should be at least twice the highest data frequency of the analog signal. This is also known as Nyquist criteria, or the sampling rate of signal. So now the quantization and encoding. Here for the quantizing there is a term defined is known as resolution. The smallest change in analog signal that will result in a change in the digital output is known as resolution, and this resolution is shown by this formula: delta V equal to VR by 2N, where V is the reference voltage range, N is the number of digital output, 2N is the number of states, and delta V is the resolution. So the resolution represents the quantization error inherent in the conversion of signal to digital form. So this is the quantizing and encoding process. In quantization partitioning the reference signal range into a number of discrete quanta, and then matching the input signal to the correct quantum with a mathematical value. And in encoding, these quantum or these mathematical values of signal is defined to a unique digital code to each quantum or So the input signal now is encoded in a digital encode signal. The accuracy of digital AD conversion depends on these two ways, that increasing the resolution, which improves the accuracy in measuring the amplitude of the analog signal, and increasing the sampling rate, which increase the maximum frequency that can be measured. Here it shows by a graphical diagram. Here is the low resolution and low sampling rate. We can see there is a data in that case which is not measuring by sampling and hold signal, so this is the noise for it. But here the resolution rate is increased, sampling rate is increased, so it covers all the data and accurate. So this shows the low accuracy and this shows the improved accuracy. In next lecture we studied about the types of AD conversion. So thank you.